The question we are solving now belongs to test series 2. It is of analog electronics subject. In specific, it belongs to op-amps. As per the question, there is an op-amp circuit which is drawn as shown. It contains it is given a input supply of Vs through a resistance R1. There is a feedback resistance R1 which connects the input terminal and the output V1, and the other terminal of the op-amp is connected to the ground by using a resistance R2, and the same is connected to ground by using another resistance RL, and the same terminal is connected to the output using a feedback resistor of R2. The current through RL is written as IL, and we need to find the value of IL. We see that the op-amps have the infinite input resistance, hence the current drawn by the op-amp input terminals is equal to 0 ampere. Because of these reasons, both the input nodes of the op-amps have the same potential V1. So upon applying KCL at the node 1 that is being marked now, and at the node 2 that is being marked now as well, we see that V1 minus Vs by R1 plus V1 minus Vo by R1 is equal to 0. This upon simplifying becomes V1 is equal to Vs plus Vo divided by 2. This is equation number 1. Similarly, upon applying KCL at the other node marked, we see that V1 divided by R2 plus V1 divided by RL plus V1 minus Vo divided by R2 is equal to 0. This upon simplification becomes Vo is equal to 2 plus R2 divided by RL multiplied by V1. This is equation 2. Upon using the equations 1 and 2, we can show that V1 is equal to minus RL by R2 multiplied by Vs. We also know that IL can be written as V1 divided by RL, hence upon substituting for V1, we see that IL can be written as minus Vs by R2. From this we see that the current IL can be obtained as minus Vs by R2 ampere, and hence the correct option representing the current through RL is A.